Next topic we are having here, weight of an object. So what do you mean by weight of an object? The weight of an object is the force with which earth attracts it. For example, here I am having one ball. When I will throw this ball, okay, when I will throw this ball from height, so where this ball will go? Obviously, it will go downside or it will move upward. No. When we will throw the ball, this ball will move downside. So each and everything, we are knowing that each and everything is going towards the center of the earth, or each and everything is attracting towards the earth. By which force it is attracting toward the earth? This is force of gravitation or gravitational force. In a same way, in a similar manner, each and every body when attracted toward the surface of earth, that force is nothing but is a weight of an object. Means the force by which this object is attracting towards the earth, that force is nothing but a weight of an object. So might be, what is weight, it is clear to you. You can see here mass also. What do you mean by mass? Side by side I will tell you what do you mean by weight. Afterwards we are having one difference between mass and weight. From there you can note it down, but still here I want to explain you. So what do you mean by mass? Mass means quantity of matter contained in a substance. How? For example, this one substance I am having. So in this substance, how much quantity of matter is contained? Matter means, as we know, each and every matter is made up of atoms or molecule. So in this material also, mass is a quantity of matter contained in a substance. In this substance, how much matter is contained? That quantity of matter will give you mass. Fine. What do you mean by weight? Weight I already told you. Each and every object is going to attract towards the surface of earth with some force, and that force is nothing but a weight of an object. This is the main difference between the mass and weight. Actually, these are the definitions related to mass and weight. See, this is a weight. When we are measuring, it is giving us the weight. Next, we are having weight of an object is the force of gravity experienced by an object. This I already told you. Whatsoever object is going towards the surface of earth or falling down, that all objects are having some gravitational force, and that force is nothing but a weight of an object. Now we are having weight is a vector quantity. Vector quantity, as I already told you, in vector quantity we are going to see magnitude. In vector quantity we are going to see magnitude as well as we are going to see the direction. So weight is also a vector quantity in which we will see magnitude, we will see direction. For example, weight is 5 Newton. So here 5 means magnitude. 5 is also important, direction also. Weight is applying downside or it is moving upside against the gravity. So that is also important. So weight is a vector quantity, but mass is a scalar quantity. In mass, we need not any like direction. Why? For example, in this matter, in this substance, these matter particles are there. So these matter particles are arranged in which direction? It is important for you? No. So in this, only quantity is important or only magnitude is important. In mass, only magnitude is important, but no direction is important. So mass is a scalar quantity. Mass is a scalar quantity and weight is a vector quantity. Fine. If m is the mass of an object, g is the acceleration due to gravity. Now we are going to do the relation between mass and weight. This is a relation between mass and weight. Weight of an object is equals to mass multiply gravitational force, that is g. And this g value, this gravitational force or gravity value is always constant, that is 9.8 meter per second square. This value is always constant. This only value we have to put. Or in sometime books it is given 10 meter per second also, meter per second square also. So this also we can take, but actually it is 9.8. So this is a relation between weight and mass. As the value of g varies from place to place, actually the value of g, gravity changes from place to place. As I told, 9.8 meter per second square. This is the value of G on the surface of Earth. This is the value of G on the surface of Earth. But when we will go on the surface of Moon, their value of gravity is different. Their gravity is less, na? So their gravity is different. So gravity changes from place to place. As gravity changes from place to place, so weight of an object also changes from place to place. Fine. Next we are having SI unit of weight. So SI unit of weight is what? SI unit of weight is Newton. Other units of weight which we are going to commonly use. So other units of weight are kilogram force. Next we are having kilogram weight. So this is the main difference between mass and weight. First difference is mass is the quantity of matter contained in a substance. Mass means what? Mass is a quantity of matter contained in a substance. What do you mean by weight? Weight is the force with which an object is attracted toward its center of earth. When object is attracting toward the center of earth, that force is known as weight. Mass is a constant quantity and independent of place. Mass is a constant, means mass is not going to change from place to place. Okay, but weight can vary from place to place. Weight we can change. Like for example, on the surface of earth, weight is different, and on the surface of moon, due to change in the value of G or gravity, the weight is going to change. SI unit of mass is kilogram. SI unit of mass is kilogram and SI unit of weight is Newton. Actually, weight is what? Weight is a force only, and force SI unit is Newton. Similarly, weight SI unit is also Newton. Mass is measured by beam balance. Beam balance might be you have seen this kind of thing like this. Two pans are there. Here string is there. These two strings are there. So this is the beam balance, and weight is measured by spring balance. In the next slide, I am going to show you spring balance also. So mass is a scalar quantity which is only depending upon magnitude, but no direction is important. Weight is a vector quantity in which both magnitude as well as direction is important. Mass of an object can never be zero. Mass can never be zero. Why? Because in matter, some quantity of matter should be there. No, in any substance, any quantity of matter is always there. So mass of an object can never be zero, but weight of an object can be zero. Where it can be zero? In a gravity free space. Gravity where there is no gravity, where there is zero gravity. So in that places weight can be zero. Okay. So next we are having relation between different units of weight. As we have learned SI unit of weight, that is Newton. Afterwards we have learned kilogram force or kilogram weight. So now we are going to see the relation between different units of weight. So first is we are having relation between kilogram force and kilogram weight. 1 kilogram force is equals to 1 kilogram weight. Means kilogram force and kilogram weight, they both are same only. Kilogram same only. Here force is nothing but a weight only. So 1 kilogram force is equals to 1 kilogram weight. And they both equals to 9.8 Newton. It is very important from exam point of view. They can ask like this. Like 1 kilogram force is equals to dash Newton. So in dash how many Newton? 9.8 Newton. Or they can ask 1 kilogram weight equals to dash Newton, that is 9.8 Newton. This is the relation between kilogram force and Newton, plus it is a relation between kilogram weight and Newton. Next we are having submultiple of kilogram force is gram force. If we will see the submultiple or the smaller unit for the weight, that is gram force or gram weight. So submultiples of weight are gram force and gram weight. So relation is 1 kilogram force is equals to 1 gram force is equals to 1 gram weight. Gram same, force is nothing but a weight. So 1 gram force is equals to 1 gram weight. Fine. 1 gram force is equals to 1 by 1000 kilogram force. Here how it comes? Here actually 1 gram force is there. In 1 gram, as we know how many kilogram are there? In 1 gram, 1 by 1000 grams are there. So 1 gram force is equals to 1 by 1000 kilogram force is same. So this is the relation between kilogram force and gram force. Fine. Next we are having weight of an object is maximum on earth's surface but decreases as one goes on height. For example, this is the earth's surface, this is the earth. When we talk about the earth's surface, surface means this full part in between the earth, this full part. In this full part, weight is maximum, weight is there. But as an object is going on some height, this object is going on some height. When any object is going on some height, at that case, weight is going to decrease. At this case, weight is going to decrease. But when object is there on the moon surface, their object weight is maximum. Okay. On earth's surface, weight is maximum at its poles. Poles means this one. This is also pole. This is also pole. Here also pole. Here also pole. 4 poles are there. Okay. So gravity weight is maximum at the poles and minimum at the equator. This is equator, central line. So at the equator, weight is minimum, and at the poles, weight is maximum. Fine. Now we are having some more knowledge. The force of the earth's attraction is termed as gravity. This we have already learned, that whatever force by which object is going towards the earth, that force is nothing but a gravity. And this gravity varies from height to height or depth to depth. Fine. As I already told, when we will go up the height, when we will go above the surface of earth, their weight decreases, but on the surface weight will be maximum. So next we are having like this, each and every object is going towards the surface of earth. So this object is also going toward the surface of earth, and at some height it is moving downside due to the gravity or the weight is there. Next we are having gravitational force on moon is 1/6 of gravitational force on earth. What does it means? For example, on earth my weight is 60 Newton. On earth's surface my weight is 60 Newton. But when I will go on moon surface, there it will be 1/6 only, 1/6 of weight of earth. If I am having here on earth 60 Newton force and I will go on the surface of moon, then my weight will decreases to, see here, 60 value put here, 6 tens are 60. So there my weight is only 10 Newton. So what does it means? Gravitational force on moon is 1/6 of gravitational force on earth. Fine. So if you want to calculate, here it will be like this, you can write, gravitational force on moon is 1/6 of gravitational force of earth. This you can write. Gravitational force on moon is 1/6 of gravitational force on the earth's surface. Fine. Like on the earth's surface, our gravity is going to reduce. Gravity reduce means weight is also going to reduce. Next we are having measurement of weight. So weight we are going to measure by using spring balance. In the difference, as I told you that mass we are going to measure by the beam balance. This is the beam balance. And weight we are going to measure by the spring balance. This is the spring balance in which here one spring is tied. Okay. One spring is tied. When we will tie here one weight, so this spring will elongate. When this spring will elongate, it will give you the reading of the measurement of weight. So this is all about your chapter number 2, that is motion. So if you like the explanation, please share it, subscribe our YouTube channel. Thank you so much.